to Scientific Computation using Python lectures. In this lecture, I want to move forward and show you how to work with airfoil data. After that, I want to show you how to create flows around an airfoil. So, in order to do this, in the last videos we have covered quite a bit. I showed you how to draw a vector, how to get the magnitude of a vector, the unit vector along a vector, how to find angles between vectors, and I discussed the projection of a vector along a unit vector. After these, we also discussed how one can draw multiple vectors on random points or grids. Once we have a grid, I also showed you how to draw uniform flows and sink, source, and vortex flows. And we concluded the last lecture discussing a for loop to superpose flows. For example, I can superpose vortex flows. That was the example we discussed last time. So, having all this information in our bag, let's continue how we can use these vector discussions when we deal with flows around airfoils. So, in order to study airfoils, I would like to show you a website that has a large number of airfoil data, two-dimensional airfoil data. Let me show you how we can get those database on our computers first. Okay, the website, the database is available on the web free of charge at the University of Illinois Urbana-Champaign University Selig airfoils. So if you search this, you can just search for Selig airfoils. In fact, the website I am talking about is this one, Applied Aerodynamics Group at the university. So click there. So there is a whole bunch of airfoil data here. There is a zip file over here, zip archive, coordinates Selig FMT zip. I want you to download this file on your computer by clicking on the file link. So let me do this with you. It's quite a small file, text, because it's a text file. So here is my file. I want to open this zip file and put the contents into the folder where my Python script is. So here is how I do that on my computer. So here is the zip file opening. So this is the file I am talking about. So all these dot files are the airfoil data files. So let me copy this file, this folder, into the Python folder where I do my coding. So here is my code. I want to paste this item here. It's a really small size folder because it's all text. So once I finish copying, I would like to show you the contents of this folder. Okay, so if you want to go inside this folder, you will see a full list of dot files. These are text files. So let's have a look at inside one of them. For example, this one. So double click to open it. Okay. So as you see, we have a column of X values and another column of Y values. We don't know they are X and Y yet, but because I worked with this already, I know this is a column of X values and Y values. You are going to discover that shortly. Also, the first line is different. It gives a coded name for the airfoil. So this is a particular airfoil. Let me close this and open another one. I need to go to my folder. Okay. How about we go to another one, a random one. Again, the first line is a single text line, and then I have a column of values. This file is fairly long compared to the previous one. And the last one, let's go to this. Again, I have a cryptic name for the file indicating the name of the airfoil. And these are the X coordinates and that's the Y coordinates. Okay. So this is the text files that I have. I want my Python file next to this folder. So I want to save, open a new Python code file and then save it as airfoils as a Python file in the same folder that your database exists. So airfoils save. Good. Now at this point we have our text files, airfoil data, and we are ready to begin with the Python script to explore the data files. Okay, let's start with doing the regular imports. Import numpy as np, import matplotlib pyplot as plt. Now, because we will be dealing with files in a different folder, I will import another library. This is the first time we will be using this library. It helps us go around the operating system, look for files, and open and close these files. So that library is the OS, operating system library, import OS. And I import it as it is. So to test that you can successfully import this, you can try running the file. So I have run the script, and as you see there is no error message. So it has successfully imported the OS as well as the NumPy and the matplotlib libraries. So where are the data files that we want to work with? So look at my airfoils file. It is in week 6 called airfoils, and then at the same place here week 6 code. So this is my script that I am currently working with. Here is the airfoils and there's the airfoils, and this is my data files. So if I go into this folder, I have all my data files. Therefore I put the directory name as this. So simply copying and pasting it here. I need a quotation marks here in order to show that it's the name of the folder. And also I want to indicate the files inside that folder, so I use a forward slash to indicate that I am looking for files inside that folder. Next, after defining the directory name, I can now call my files as operating system dot list the directory and supply the directory name. What is the directory name for my airfoils? Well, it is the one that I have defined up there. So these two lines actually access all the data files that are in the folder. Let's see. So let's begin by running this code. Okay, let's have a look at our variables. There is the coordinate select fmt folder name, and look at the files. So here's a whole bunch of files that we have in that folder. So let's see how many. How can I, let's clear this. How can I check how many files in the folder? Well, because files is a list, I can get the length of that list files. So we have 1550 files. What is the first file? Okay, and what is the next one? And what is the following? And what is the last one? How do I check the last one? So it's the last one. Okay, I just want to show you this is the first file, and let me go to the files list here. And show you that this is the first file, and this is what the file looks like again. First string and then next numbers. Okay, let's clear the screen. Now, how do I actually load the x and y coordinates from the file? This is for that I use the NumPy library's load text function. So which file I want to load? Let me do it this way. File name is the directory plus files. For example, let's open the first file. Let me run this again and then show you what file name is. So it is this folder name plus the file name with the dot extension. Good. So let's say array is numpy load text, load this file name. Okay, so I am supplying the file name, which is the full path name from this point, the folder's name slash the file's actual name. So if I supply it to load text function, I can get my array. And now I want to bring something to your attention here. If you remember, the file name has a text at the first line. So this is not a regular XY coordinate. So I must skip this row. So in order to do that, or let me show you without doing it first, and then see I am getting an error response. It says could not convert string to float, and this is the string that it cannot convert. Here is the file. So here is the file, and yes, it cannot create this first string into a number, and that's quite reasonable. So in order to deal with this load text command or function has a parameter called skip rows, and I want to skip one row. That will be in this way I will be able to load the file name contents into the array. So let's run it. This time it runs without an error, and let's have a look at the contents of my array. Yes, the array variable is now a numpy variable with 2 columns of data. The data is the same that we see for the dot file. Okay, array, let's see the shape of the array. So it is a 2-column array with 35 rows. In fact, these are the x values and these are the y values of my folder, of my airfoil. So let's unpack that. The x coordinates of the foil are array. So how do I select this first row, first column here? It's all the rows and the first column. So all the rows and the first column of array. Let's have a look. Foil x. So yes, I have extracted the first column and made it an numpy array called foil x. Likewise, I do this for foil y. Foil y is of course the next one, next column. So we start from 0 and this is the next column, column 1. Okay, foil x and foil y. Foil x, foil y. I have my coordinates ready now. I think at this point we can just draw them, plot them in a graph and see how they look like. And then I will do it here. PLT plot foil x, foil y. Let's plot this as is and we will do some improvements next. Okay. What do we see in the plot? Well, y values go from 0 to 0.1 more or less. So there is minus values here as well. And the x values go from 0 to 1. 1 point is the end of this foil, the tail end of this foil. These 2 points are not closed. Maybe it's a good idea to close them in a while. So I want to improve this plot a little bit by doing what we have done in the past. Let's bring figure and x plt subplots, and then let's do the aspect ratio 1 and do x limits and y limits. So for the x limits, I think it's reasonable to make it from minus 0.1, 0.2 to 1.2, and the y limit, I think I can safely say it can be from minus 0.2 to 2. So actually in the y, I am making it a little wider than it should be. But for some airfoils, I think this y limit is better. Okay. We can also perhaps do the title of this graph. I can use this one, files 0, as its title. Files 0 as its title. So let's run this as it is and then see what it looks like. Okay, now it looks much better. Before I say anything else, have a look at this. These 2 points are actually open, but we cannot see it in this representation here. Besides that, so here is my y-axis, and then this is my x-axis, and the airfoil, I can see it beautifully there. Okay, well, let's have a look at other airfoils as well. For that, I want to do something like this. So this is the first file I am plotting. If I give it a parameter, a variable n, and then load n over there. So this one should be n as well. Run it to get the same thing. Okay. Okay, now by changing n, let's have a look at different ones. So this is the first one. It's the second one. And this is the third one. And the fourth one. And the fifth one. Very good. So I can see different, I can load different airfoils and investigate them further. If you don't want the extension dot here, you can remove it by not taking the last 4 characters there. So that should be something like this, I think. So in that case, I don't have the extension. Okay, let's come back to our first airfoil again. I can do something more here to make it visible, to make it a little larger. I can supply a figure size, and then I can give a figure size of 12 and 10. Let's see how big this is. Okay, it is good. Now, how can I deal with the endpoint over there that I actually bring to your attention a little while ago? If you look at the foil X array, it goes from 1 to the front end and then comes back. So from trailing edge to from the trailing edge to the leading edge, and then from the leading edge back to the trail edge. This is how the foil, the X components go. Let's explore that with a plot. Foil X. So the foil X coordinates start with 1 and go to 0, and then from 0 back to 1. If you prefer this, sorry, I forgot to plot foil X. I want to show you the X points. Okay, it's sampled more towards the leading edge. I can see it here, and it starts with 1 and ends with 1. How do I see that? Foil X The first coordinate is 1 and the last coordinate is also 1. How about the y coordinates? So it begins with this one and goes to that one over there. So it doesn't go to the same coordinate. Let's plot it to see what it looks like. So the y coordinates starts from 0, goes up and then down, and then goes again up and down. So this you can see it from, let me run this part and then make sense of the y graph. So the y, look at the y coordinates, they go up and down, and when you're on the bottom side it again goes up but not as much and then comes back to near 0 towards the trailing edge. One trick we can do is to set the foil y, the first coordinate, to make it 0, and the last coordinate make it also 0. So look at foil y. Okay. By making these two changes, am I not changing the foil? Yes, definitely. I am doing a change here, and I should take all responsibility for that if the aerodynamics of the foil is changed. But since I know what I am doing, I can do this kind of change at this moment. If I plot the foil y coordinates again, okay, and then this is actually I made explicitly this first and the last points coincide. Just check foil x, foil y. So starts from 0 and ends at 0. So they are exactly the same points. How do I know that? Because foil x, so the coordinate of the first point is 0 and 1, and the coordinate of the last point is again 0 and 1. So they coincide. I made the trailing edge coincide. Well, why the database didn't do that? It can be due to any reason. The point of using Python in exploring this is it gives you the chance to do that. Okay. How about we conclude this first introduction part by doing this for a number of, so, this is what I want to show you the airfoils in order. Let's do this for n in range beginning with 0. Let's have a look at the first 10. So if you do a for loop like this, so for n equals 0 up to 10, I am loading the files, getting the foil x's, and then plotting the foil. So plt show would make sure that the next one appears after the first one. And I can do a little bit of sleeping here using the time import that we used in the past. Time sleep for 1.5 seconds. So let's have a look at this in order. So that's my first one. Second one. It's clear that this is not closed as well. Okay, now this one is more closed. Okay. I can make my foils trailing, I can close the trailing edge by making the foil Y coordinates 0. The first one and the last one. If I make this both 0, I will have a closed trailing edge. Let's have a look. Okay. We can also have a look at the actual points, airfoil points. Let's run it there to see the sampling as well. Okay, I can do this for the whole data file of that 1550 airfoils, but I will confine our study to this few airfoils. At this point, we are ready to do more with the airfoil panels, etc. And in the next part, I would like to show you how we can explore the geometry of the airfoil further.